In this video, we're going to be discussing and introducing a new way to measure angles in a circle. Most people know the way of measuring this is by degrees. And this can be a little confusing if you think about it for too long, because we know degrees as degrees of a circle or degrees of an angle, but degrees can also be representing temperature, Fahrenheit or Celsius. And even beyond that, if you think about latitude and longitude of the Earth, those are also measured in degrees. So these are three different ways to represent one thing, or kind of makes it a little ambiguous. In addition, we also have 360 degrees in a circle, which is also a little ambiguous because that kind of comes from ancient times where they figured out that there was 360 days in a year. So that was kind of going in a circle, and they kind of applied that to the degrees in a circle as well as the days in a year going around the sun. And that kind of all came together to be 360 degrees in a circle. And there's actually a much better way to think about it. And we're going to use this following applet to explore that idea and introduce what is known as a radian. So looking at the circle we have in front of us, it is pretty straightforward right now that we have a radius length, and then you can see this blue line is also a radius length. You know that they're the same because they both have one little line through them, and that's the geometric symbol for two segments being equal in length. So if I start moving this, I can see how I can kind of make one radius length. This full thing in blue, and I can go a little past it so you can see it. So that one in blue is one radius length, the same length as the radius we have right here. And we're trying to see and answer the question, how many times will a radius wrap around the circumference of a circle? So if we follow this around, we can see we got 2 is that orange one, 3, 4 radius lengths, 5 radius lengths, 6 radius lengths, and then we don't quite go to our 7th one. We actually have 0.28 of a radius length left over. So if you look at what just happened there, we have 6.28 radius lengths around the circle, which should actually make a lot of sense to you, because if you think about the circumference of a circle, the formula is 2 pi r. And so if we do 2 pi, 2 times pi in your calculator should equal about 6.28. So really the circumference formula is saying you just take 6.28 of your radius lengths and lay them all in a circle, and that would make up the circumference of that same circle. Now, if we continue with this applet, we want to look next at how we can kind of relate that to radians. So if we think about going all the way around the outside of a circle, that's 360 degrees. So we're saying that that 360 degrees, that would be 6.28 of these radius lengths, 6 and 0.28 left over. And we can draw basically angles around the inside of the circle, like so. So we have one radian is basically hitting this arc length right here. So if we know that like this line from the very beginning, that's the same length as this arc. And then we also have another radius right here. So now we have an angle made basically connecting two radius lengths to the outside of the circle from the center. So if your arc length right here, this blue line right here, if that is the same length as your radius, that angle that you're creating is just 1 radian long. So we basically can go all the way around the circle, and we have all of those pieces filled in. So we have 1 radian, it would be the angle hitting a 1 radius length arc. And then you have 2 radians, 3 radians, 4 radians, 5 radians, 6 radians, and 6.28 radians. So what we have concluded at the end here, and this is the most important thing, is first that an angle that's 1 radian, that would just make an arc that would be 1 radius long if you're drawing that angle as a central angle. And second, that we have going around the circle 6.28 total radians that makes up a complete circle all the way around. That tells us that 2 pi radians, or 6.28 radians, is the exact same thing as 360 degrees. And that is a very important conclusion we have just found right there. I wanted to show also this quick animation showing exactly what is happening with that 1 radian measure. So if I click to start this animation, we have basically the radius length that is going onto our arc measure. And you can see how the arc measure is 5 and the radius is 5. And we have a central angle created right here with these dotted lines. These dotted lines are also radius lengths. So if we have these radius lengths going from the center to the outside of the circle, if they're hitting an arc that's the exact same length as my radius length, that means that angle is 1 radian. And that is something we want to make sure that is understood because it's easy to misinterpret what a radian is. And just a thought on where the word radian comes from, it really just comes from taking radian units and putting it into one word. And to finish off, we wanted to look at one more applet that demonstrates what we've been discussing with the radians during this video. We're looking at an example here where we have a radius of 4, and it shows the arc length and the radian measure. So if we take our arc length out to 4 to be about equal to what the radius is, our radians are about 1. And then if we take it continuing around the circle, our radian measures are getting bigger. And you can see that the radians are basically just a ratio comparing how long the arc length is compared to how big the radius is. And if we go all the way around the circle, we can kind of see that that radian measure is matching the ratio to the green angle we're making. And we're going all the way around the circle. And if we go to the very end of this circle here, we have 6.28 radians like we discussed before. We have 1, 2, 3, 4, 5, 6, and 0.28 radius lengths around the outside. And you can see the arc length, that would be the full circumference. If I took 4 times 2 pi, I would get 25.1 as my circumference. So in conclusion, we've talked about that there are 6.28 radius lengths around the outside of a circle, meaning that there are 6.28 radians in a full circle, which would equate to 360 degrees. And lastly, 1 radian is an angle that would hit a arc on a circle that is exactly 1 radius long. And that covers this introduction to radians. Thank you for watching.